We are making progress. And now that we have a way to compare player seasons and sort based on a single percent error, we can identify the 10 players with the most similar seasons. If you recall how our projection model works, we are going to take each of those 10 players and look at their stats for their next season and average together all of those stats to project our current players next season. That's a mouthful. Our assumption is that our current players next season will behave very similar to those compared players next seasons, since they all had similar stats in the comparison season. The reason we are taking 10 of them is to account for any inconsistencies and to use an average. But we won't just take the straight up average of all 10. No siree, Bob. We are going to take the weighted average, meaning if one of those players had a very small percent error indicating nearly identical season stats, then we want to use that player's following season more heavily than others. What you may see here too is that similar player seasons could be the same player but a different season. This is fine. If anything, you're probably most similar to yourself. We will add in some logic to help account for your own seasons. But first, let's go through the process for how we are going to take the following season stats and how we can weight them appropriately. First things first, we need a list of all the season IDs. Let's create this as a season list and add in all the season IDs. Let's add in the 1819 as well. From here, we are able to access a particular season in the list with an index. Remember that the list index starts with 0 in Python, so the index value for 1996-97 is going to be 0, and 1997-98 will be 1, all the way to 2018-19, which is indexed at 22. So if we wanted to access the 2014-15 season, we would use the index value of 18. So we could get our season ID, which equals our season list indexed at 18. And let's print our season ID. And you'll see we get that 2014-15 season. But what if we knew the string and not the index value? We can use the index method for times like this. So let's save the 2014-15 season to a season ID variable and then call the index method by passing it the season ID. So if we said the season ID equals 2014-15, then we want the season list indexed at the season ID that we just created. Let's save this to some arbitrary variable value and then print the value. And there you'll see we get that 18 as the index. The index method gives us the lowest index in the list where the element we search for matches up. If it is not in the list, then we would get a value error. This is great, but what we're really after is the season string, not the index value. So let's wrap our value in square brackets and get the item we are actually after. So if we were to say season list, and that is going to be the season list index for the season ID. And here we'll have our current season. And then we print our current season. Voila, we get the 2014-15. So what happens if we wanted to do the same thing but get the next season? So let's say we had our current player season, which is 2014-15, and we want to get the next season in the season list. What we could do is basically take this same value and say, hey, give us this one, but add 1 to it. So now all of a sudden, the next season equals the season list where we're finding the current season ID in the season list index and then adding the next one to it. So if we were to print this, we get the 15-16 season. Good stuff. Now we'll be able to replace season ID with the season ID in a given data frame row, and we can find the next season for any given player. So, sorry for the tangent, back to getting the weighted average using one player. We have the following information: the percent error for a compared player, that player's player ID, and the way to identify the next season for that player. Our current player, if you remember, is Drew Holiday, and we compared him to a random sample of 10 players, which was stored in the ranked DF data frame. Let's inspect each to remind ourselves what we're dealing with. So if we took the ranked df head, this is our similar player list data frame. And if we print our current player ID and print our current player season, we should get Drew Holiday in the 2016-17 season. For demonstration only, let's take the weighted average of a player's season stat based on the percent error. Then we can build up how to take the weighted average of the similar players next season and eventually get the weighted average of the 10 players next season. If we inspect the data frame, we will see that the closest player in similarity based on the percent error was Vince Carter's 2009-2010 season. Let's save Vince Carter into his own data frame by taking the first row of the ranked DF. So if we take just this test DF, we took the ranked DF of location 0, this will basically give us a data frame of just Vince Carter's stats, which is really going to be just a series. To get the weight we will use for the average, let's divide the distance by 1. So we will say the weight is equal to 1 divided by the test DF, and we can take the distance, and that means if we print the weight, we get 6. And we can access the distance directly by chaining it to the data frame we created. Next, let's create a list of the columns we want to loop over. We only care about the stat columns and not the player ID or season or games played, so let's create a list that we can use in the for loop. We'll just call this stats, and I'll drop in the stats we actually care about. Now, let's create an empty dictionary where we're going to store these stats. We can always turn this back into a data frame later. So the projected stats will be an empty dictionary, and we can write a for loop to go over each stat and multiply the value by the weight, and then divide by the weight to get the stat projection. The reason we divide the total of the value by the total of the weight is because we want the weighted average. For a single player, this doesn't necessarily stick out as important, but when we take the weighted average of 10 players, we'll get a better answer. So basically in the for loop, we can say for the column in stats, take the sum of the stat that's equal to the test df, which is the column, times the weight, which again, our weight right here is the 6.00. And then we are going to add to the projected stats, let this know it's a projection. And this is where we take the sum of the stat divided by the weight. And we'll run this. And now basically our projected stats for Drew Holiday using just Vince Carter would be, oh, and I wrote porridge, but that's okay. 16.6 points per game, 5.8 field goals made on 13.5 attempted. So these are basically our stats for Drew Holiday if we used Vince Carter as a similar player and weighted the distance. Let's see what happens if we use all 10 players in the ranked DF to get his projected points. Again, let's create another empty dictionary. It will override the one up top. Now we want to create an empty total for the sum of the stats and the sum of the weights, since we will be adding to them as we loop over. So our sum of the stat equals 0, our sum of the weight equals 0. And now let's loop over the 10 players and sum up the stats and points. So if we said for row in the ranked DF iter tuples, we want the weight equal to 1 divided by the row's distance. And then we want to get the sum stat to add that, the points times the weight. And then we want to know the sum of the weight. And again, add that weight to there. So now we're looping over. We're adding the stat total there, which we're getting by taking the points times the weight. And we're taking the sum of the weight and adding it each time we loop over. So here, we run this. And to do the same thing to get the projected points, we would then just take the sum of the stat divided by the sum of the weight. And now, if we got the points for every one of the 10, we would project only 9.3. Now again, I think this is a little off because we were using the random players, but you'll see how it's different when we use the weighted average for each of them. Okay, so we just got the points for now, but what if we wanted to loop over all the columns? We can combine these efforts into a for loop. So we'll say the for column in stats. Again, we have that stats are the ones we care about. Now we can reset this equal to 0. We can set the sum of the weight equal to 0. And then what we're really doing now is for the index row in the ranked df. This time we're going to use the iter rows. Our weight is going to be equal to 1 divided by the row's distance number. The sum of the stat will be plus equal to the row of that specific column we're looking at times the weight, and the sum of the weight, we're going to add to it just that weight. And then we'll come out of that for loop and say our projected stats for this player ID, which is equal to our current player ID, which is Drew Holiday. The projected stats, projected season ID, and we're just adding this to give us a little bit more information. And this is where we're basically saying our current player season, if you remember, we want the projected next season, so we're adding that +1 there. And then let's actually add in all of the projections. All right, and if we run this, and now we can look at the projected stats for Drew Holiday with all of the 10 player stats weighted, which if we look at the projected stats, we see we have projected player ID for his next season. And here are all of his projected stats, which are in a dictionary, but we can convert it into a data frame. Now, this was using all of the compared players' current season, but what we really want are these players' next season stats, which means we need to refer back to the master data frame that contains all of their player seasons. So if we wanted to get the weighted average using multiple players next season, we will do virtually the same thing. However, we're going to replace the data frame